Welcome to this session. It's always important to make sure your environment is set up correctly. To get to your folder, a shortcut when using terminal would be going to the terminal and typing cd for change directory space, and on a Mac you could just drag that folder right next to the cd command and press enter. If you do a list, you can see that now I am within that folder, and I'll use clear to get to a blank slate again. The next step is just to make sure all my environments are set up properly. So I made a file called ready.js, and I'll type in my node command, node space 00, the file name, ready, and I'll press enter. And I'll get the feedback ready to work, just like it says here with the console log, ready to work. By doing this, I'm sure that node's working and I have the correct path to do the work. Today's lesson's three main concepts are being able to input information into your node project, being able to write a file out to the file system, and being able to read that file back in. Putting those concepts together, you'll see quickly how you could make something that's very flexible, such as with user input, they could pull in a particular file or enter information that is then written to a file. So let's get started. With solution 1, we're looking for two inputs that are typed in the terminal window. And if the two inputs are equal, but not just equal, and the difference between the two is double equals mean they could be of different types and still have a match, while a triple equal sign checks to make sure that the types are the same. Types being, are there integers, strings, objects, and if so, do they match? This file will look for two inputs from the command line, read the inputs, and pass it through this if statement. And if the two inputs are of the same type and are equal in value, then the console will log true, else console will log false. And at the bottom of this script is one other if statement that takes in argument 1 and looks for the remainder when it's divided by 7, and does the same thing for argument 2 and looking for a remainder when it's divided by 7. And when these two values are added up, tests to see if it's of the same type and equal to 0. If it is, the console will log true. So I'm going to run the script and let's see what happens. Node 01 a solution underscore 1. True. Because my two arguments that were passed in were nothing. If I rerun the script, and I'm going to press the up arrow on the keyboard and type in two numbers such as 4 and 4, I'll get true again. And if I rerun the script and instead of 4 and 4, I type 4 and 3, I will get false. If I rerun the script and I type in 7 and 7, I get true and true, which states that on line 6, argument 1 is equal to argument 2, and they're of the same type. But not only that, that when we divide argument 1 by 7, we get 0. When we divide argument 2 by 7, we get 0 remainder, and that is equal to 0, which gives us true. Now, to make this a little more clear, instead of just printing out true, I could clarify which true is which true, because earlier on, when I was doing these console logs, we're not sure which true is coming up. So for clarity, true final if. And after I save it, I'll rerun the same exact command, and now not only will I get true, but I'll get true with the true final if statement. This will add clarity on which part of the if statements are responding. If I do the first scenario where I don't pass in any arguments and I hit enter, I know now that the true that I'm getting back is the true from this if statement, and it's not the true from this if statement because that true says something totally different now. Solution is like the previous solution, except it's way more condensed. You should take a moment and compare the two together and see how, in the end, they produce the same exact functionality and result with fewer lines of code. Here we have two console statements. The first one looks at the two arguments and does a comparison. And if they're both equal to one another, just like in our previous example, the first part of the if statement, it's going to produce a true, while if they're not equal to one another, like the else part of the if-else statement, it's going to log false. And then, in the last line, takes the if statement of the previous example and condenses it into the same one-liner. It does all the math to look for zero remainders on both to console log a true or false. So running an example, I'll first put in a very true statement, 7 and 7, which gives me true. They're both equal to one another, and both will have a remainder of 0, which equals to 0. If I do if I run it again, and I use -7, the first is false because 7 is not equal to -7. However, if you divide 7 and -7, both equations give you a remainder of 0, making this a true statement. So here's an example of first you can write code, and as you figure things out, you write it in a way that makes sense to you, sense to anyone else as you refine the code. Then you could take a step back from your code and wonder, is there a better way to write the code that still makes sense to you and someone else who has to look over your code, yet does it in fewer lines? And this example of solution number 2 does just that. In the previous example, we were inputting information, but at some point that information has to be processed. And there's different ways to process that information. One way would be to feed that information into new functions. Another way would be to write that information, whether it's writing to a text file or a database. That information that we input can be stored. In this example, we're going to focus in on just writing out a text file. Later, we'll read in that text file in the next script, and then later on, we can use the arguments that we can input with a command line in order to influence the writing and reading of text. Line 1 is all about giving the script the functionality of file systems to be able to read and write files. Line 6 about naming a file to be saved, passing information, the content, into that file to be saved, and handling an error. If I run this script, we should get a new file called movie.txt with these two comma delimited pieces of information in that file. And then we'll change that up in a second. So node space and the 02 underscore write, and I'll hit run. And I get a message, movie.txt was updated. Movie.txt was updated. So let's say I don't trust that message. I need to actually see the file. First I could do ls for a list, see everything in my directory, and sure enough there's a movie.txt here. If I want to read that movie.txt, I could type in the command line can't movies.txt, and I can see it listed out here. Another way to display out the contents of a text file, let me just clear off everything, would be to type in less and the name of the file. And this gives you a cleaner way to look at the file, and when you want to exit out of this, you press the Q key. So two different ways. One will be can't, which gives you an inline viewing of the content. And let's say inline viewing would be a little visually disruptive to your terminal window. So your other option would be using less.movies.txt to view the file and then pressing Q to exit. I can see that this script is functioning. Now to show you what information you as a coder could change, let me just go straight off to line 6. Instead of movies, let's say I wanted to do a text file based upon Star Wars characters. And in this list, I then type in a few characters' names such as Darth Vader, Luke, Yoda. And then I go down here and just let people know that, yes, new file was created. This way, I can see that whatever the name of the file has nothing to do with that console log message. And then I have to save this file, Command S on a Mac or Control S on a PC. So that way all my changes have been saved. And when I run this, I could see that I have my new message. Yes, a new file was created. And if I do less and the name of the file, which is starwars.txt, I should see my new input information. There we go, Darth Vader. Oh, Darth Vader. Darn, typo. Well, see, Darth Vader was the friend of Darth Vader. Long story. Anyway, I see I have to correct that. So let me just correct it here. Command S. Quit, run it again. And look at that. The real Darth Vader has showed up this time. This also shows through my typo that the file that is being created is being overwritten. Let me quit out that. So the last thing that we could do with this is make it variable, which means, let's say I just want to have more flexibility on naming files. So I could type in variable file name is equal to starwars.txt, variable characters is equal to, and I'll type in again Darth Vader, not Vander, and I'll mix it up, Yoda, and then Luke, and put a semicolon at the end. I can now use these variables as the parameters being passed to write file. So I'll use file name, and in this position, I'll use characters. And just to make it a little more fun, console log, yes, a new file, comma, the name of the file happens to be file name. And I create my string like this, where I'm using the variable of file name to be filled into my success message. And when I save this and run it again, well, first I could see, yes, a new file name and the name of the file here is printed into the terminal window. And this variable is picked up from here, which is picked up from here. And now when I look at the file itself, you can see that the new order is written. Darth Vader, Yoda, and Luke. Darth Vader, Yoda, and Luke. Now the script is exactly the same as previously, except I'm using variables to pass in parameters. So you could see where that might come in handy when that list gets a whole lot longer. So this way it's cleaner to read characters and know what characters are and to pass it in the script, and it also would make it more flexible. Later on, you can make this a general function to take in any file name, any piece of content, and write it out. So this way you don't have to keep on writing unique instances of a function every time the text and the file name changes. We just wrote out information to the file system. We have to be able to read that information back into our script in order to utilize it within an application. And also in a few scripts now, we'll see about reading information that's not local but is somewhere else out on the web. So this script, its first line, which is line 2, requires again the same package of file system. It's got a console log that it's reading or it's about to be read. And its function will take in a static name, such as movie.txt, the format of the stream data, and that error function, what happens if something goes wrong. And it's going to read in the text file, and it's going to take the data and create an array that's delineated by the commas that's in the text file, and then it's going to console log out that array to the terminal window. So, running this script, node 03 read. It's going to open up the movies text, reading that data from the movies text, split it into an array based upon commas, and then print it out to the terminal. And there it is. Console log. Here's the array that was created here from the data that was pulled in. So combining what we just did, the three main parts, we have the ability now to enter an argument on a command line or within the node script itself, write out information, and then the ability to read back that information. Take a moment and think about the many different uses that these three tasks can allow you to do now, such as now if someone signed up to join a community, you can have them enter information into an input field, write out that information to a text file, and then read back that information later on so they could complete their bio. Now, saving out as text file is great, but later on, that information probably should be saved out to a database that could write and read information and search through information a lot quicker than text files.